Good morning. As you've seen with DC-MHS, we're here to talk about how to achieve hardware interoperability and as well as firmware and software discoverability within the platform enablement domain so that we as an ecosystem can have interchangeable HPMs, SCMs as needed, and as well as extending that into the different peripheral domain. So we're going to talk about the journey and the steps to get there and the current efforts to achieve this. So I'll talk about the vision and the focus on the hardware. Phil will talk about the transition toward plug and play and maybe ultimately plug and ship. And then Javier will talk about some of the more concrete FPGA and the things because HPMs aren't truly stateless in order to be able to fulfill this vision. So we're trying to achieve the hardware and the firmware interoperability between not just the SCM and the HPM, but also the peripherals that are seen from the SCM through the HPM, and commonize the non-differentiated elements of the HPM so that the innovation can happen within the HPM vendor and the CPU vendor complex. But all of this stuff that's around it to enable those are, where there's a lot of arbitrarily different solutions. We're trying to overcome those and create them basically all things equal so that people can still build up different configs within all the different HPM form factors, and then be able to have confidence that when you create peripherals such as risers and backplanes and things like that, that you can be able to understand that they would be easily discoverable in terms of bringing your platform online. So currently with the base specs that have been out for 1 year now, they're continuing to evolve. They're very much focused on card electro-mechanical domain for the most part, and some, the electrical interfaces to the connectors that are ingress and egress on the HPM itself. But with those become a lot of menu of options as well as some implied needs to be able to go through discovery in order to bring some of those interfaces alive, be able to negotiate the different functions on the different pins, that sort of thing. So it's not really well create that. Today you have to do kind of a hardware software co-design, a hardware design of all elements yourself. And we're trying to make sure that the HPMs can come in. And so what we're doing is, under the work underway, trying to overcome the yellow and the red areas between the logical and then the electrical and then the firmware domain in order to be able to obviously achieve the goals we mentioned. So from a big picture, today we're at the base specs. Like I said, card electromechanical. You have safe. SCM can engage in terms of understanding which HPM is there and proceed if you know what you're coupled to and right rev the firmware and all these sorts of things and build your own sort of way. And then, but there's really no DC-SCM or guaranteed hardware interoperability. And so we're working on the first phase is the hardware interop. That gets us to what we call plug and code. So you're guaranteed when you generate, you couple any hardware element to an HPM, it's not going to blow up. And with only software, you can now bring to life the system you're trying to create. Then after that, we've already kicked off an effort, Phil will talk about, around the things in the firmware domain, the programmables. As I said, the HPM is not really truly a stateless entity. There's FPGA code, there's lots of things that are just, that we're trying to, like I said, flatten and make sure that if they're not non-value added differentiated features, that an HPM supplier can produce that with ease. And then subsequently, there'll be some far-off phase that's related to hardware-software co-design, being able to automate a lot of the hardware description elements directly into firmware and things associated with that. So from the first phase, what we've done is, and it's publicly available right now, we've released the 0.5 version of what we call an HPM common circuit design spec. So it's more specific than a base specification that gets into the logical and the electrical domains in order to create the rules and the behaviors and the and common terms and common power states as you're trying to integrate an HPM into a product. So you see that when you, around in this drawing, the HPM vendor has their IP, has their specifics for, think power sequencing and resets, things like that, that are always having to be done. You know, that's fine that they're delivering that piece, but we're trying to get this common circuit that is everything that routes through the HPM and interfaces into the HPM in a rule-based way, and choices of how to do fan-outs and how to do the various types of interfaces from a menu of options. You look at every one of those modules that couple to the HPM, and every single one of them have some set of, well, this is a flexible I/O, you can do it as you please, and we're trying to basically collapse all that into, this is exactly how you can use it, but in a way that when you couple things like peripherals to that HPM, you can discover it and configure the I/O and the bus redirection and things of that nature. What we're not trying to do, to a question that came up earlier, is create an approved vendor list of components on that HPM. But it's rules around how you do the fan out. But unlike in the MPIC spec, where we do have a table of these are approved connectors for every variation, we don't want to overly dictate which components people use. For example, the HPM FPGA, we know there's going to be 3, 4 variations of that, so we're trying to dictate at a logical domain how you would implement that regardless of which component you use. So we have released what we call the Type 1, which is it's at a 0.5 now. It did focus on the DC-SEM to HPM interface. It is a specific order off of the menu of options on a DC-SEM that currently has 1, 2, 3, 4 different functions on a pin, and we've all agreed there's at least 8 companies that have signed on to this so far that have said, yep, this is exactly how I want to use these interfaces. So now, as of this version, pending getting it to a 1.0, which includes more electrical details like you know, capacitive load, pull-up resistor values, things like that, more in the electrical domain. But you know, you can go about anyway, you know, being able to have that true hardware interoperability. And so we've defined specific hardware topologies, rules for the interfacing, the exact set of interfaces, and then the common terms and the power states as you would progress through boot sequences and things of that nature. And now Phil will talk more about, once you have that hardware interop, how do we get further into the plug-and-play domain?
All right, thanks, Tim. So I'd like to sort of zoom into what it means between, you know, in our phase 3 to get to plug and code to plug and play. Plug and code, we're looking at plug and code 2.0. I think you understand, I'm going to kind of try to define these loosely because in actual specifications, we're going to have definitive definitions for these. But plug and code is basically, well, you stick all the components together, you write the code, and that's going to be all the work is on you. So we realize this is going to be a long term, you know, it's going to take quite a lot of time to go from plug and code to what we call baseline plug and play. So we introduced an intermediary step called plug and play light, and for lack of anything better. But the idea is that we're going to spend a lot of time, you know, multiple years to try to define the interoperability framework. What that's going to comprise is a whole set of design specifications. One being the interoperability specification. What is that? That's sort of an overarching spec that sort of defines what's required. How do you measure conformance? It's really going to be a spec that's going to point to a bunch of other specs, supporting design specifications like HPM FRU. We want to transition that out of the SEM and into its own specification, and then create other FRU specifications for options, risers, and anything else that has a FRU. And in addition, we're going to be creating half a dozen to a dozen different design specs. And I've got an upcoming slide that talks further into that, really digs into that. And then sort of beyond plug and play light, which is there's essentially a bunch of specs that you can use to reference to build your particular platform. We're going to go from there to actual baseline plug and play. What do I mean by that? Again, I'm going to have the precise definitions later, but right now it's you take essentially a bunch of configuration files, you describe your platform, you know, basically in your OpenBMC or whatever you do, you fill that out, you know, hit build, and it's got the definition in there. Same thing for maybe your core boot or UFI. You've got a bunch of configuration files that describe the system, and then now you've got your firmware, put it on the, flash it. After you put all your system together, all your components, and voila, you've got a booting platform. That's the sort of grand vision. We want to get from 2 to all the way to 3. But we realize with interoperability realization, that's going to be tough because we don't even know all the additional specifications that we need. But you can see a laundry list of things that we think we need, like being able to enable OEM extensions, being able to have all of our design specs complete, and then being able to measure conformance and basically specify the requirements. How are you going to measure conformance? How do you define conformance for a set of DC-MHS components? So that's sort of here's the grand vision. We zoomed in a little bit to try to see, we realize this is going to be a multi-year journey. You can go next slide. So I talked about the interoperability specification briefly, but let's sort of click into that. What is the interoperability spec? It's going to be a spec that's going to define what's required. It's going to define interoperability. We don't even have an industry definition of interoperability as it pertains to DC-MHS. And then we're going to say, well, this is what's needed. This is how we measure conformance. And then essentially, it's going to be an overarching spec that points to, and you see the little pointer there, pointing to a whole bunch of other design specs. And you can see that this is a non-inclusive list. We realize that there's probably specs that we haven't even considered yet. But some of the things that we, sort of the low-hanging fruit, FRU, SGPIO, FPGA, discovery process, et cetera. So we're looking to the community to say, hey, we think you left this one out. Well, great, thank you. We will go ahead, and what we want to do for each one of these specs, we are starting up a work stream. We're starting up an interoperability work stream, a FRU work stream, SGPI work stream, FPGA, et cetera. So we're going to need a lot of help from the community to make this happen. But we're sort of between, in the CLA, we are trying to get this started. We've got some initial things going, but very soon we're going to want to go to the core teams and say, we want real official work streams started up. So next slide. So I talked about the work streams. Again, this is sort of giving you sort of a phased approach here. We realize that some work streams are going to start sooner. Like for instance, we've already started a very, very bare bones initial HPM FRU spec. And so we wouldn't transition what's in the SEM spec into that spec officially until that spec's like a 1.0, and then we do an addendum to the SEM spec to say, let's move it out. The contents would be the same in both for the existing multi-record. But what we actually envision is adding additional multi-records to provide self-describing JSON formatted data in there so that you can actually, firmware can look at that and go, oh, I understand the topology. That's great. And so you would be carrying that in your FRU. And so in that spec, or in the spec that we have today, it's basically just a table of contents and headers and so on, and a description of what's in there. But we're going to be putting in, as the work stream starts up, start putting in those ideas, and then hopefully getting community input into that as it proceeds down the path to 0.3, 0.5, et cetera. Same thing for all of the other supporting design specs. We've already started thinking about the SGPIO, thinking about FPGA, et cetera. So as you can see, there's a ton of work. Sort of the sort of more ambitious goal is by this Summit 2025, we're going to have 0.7s, if not 1.0s of some of these specs. That's what, at least that's what we want to do. But hopefully next year this time we'll have 0.5s or 0.3s. And certainly it's a ton of work. Again, we need a lot of support. And with that, we're going to kind of provide you, sort of a one click deeper into one of those work streams. And Javier is going to go through some of that.
Yeah, thanks, Phillip. Okay, so as Phillip was mentioning, we are going to start triggering up some of the different work streams. One of these work streams is the host processor module FPGA work stream. And what we're trying to do here, or what we have realized by studying these different elements on the HPM, is that we can probably standardize the way we can design the HPM FPGA design so it can be compatible across the different HPM vendors. In this concept that we have here on the right hand, you can see in the middle these small building blocks or standardized IP. That is what we believe that it can be standardized across the different HPM vendors. And the intention here is to provide some framework and APIs so the host processor module vendor can do some customizations on top of it. Like for example, the power sequence of the CPU that is specific to each of the HPM's designs. well, the HPM vendor can use these APIs and communicate with the standardized module or IPs that we are proposing to make the HPM compatible. Okay? The intention of all of this is to simplify the HPM logic and design that we have, the HPM FPA logic that we have on the baseboard and minimize changes to ensure that we can have some interoperability between the host processor module and the DC-SCM. At the same time, we are also enabling system integrators to build on top of these APIs on the HPM FPA so they can insert custom logic and provide differentiation on this HPM design. Okay. Just one last note here. We have started, or we believe that all of these functional blocks that we're defining here on the black boxes can be open source, or that's our long-term vision when we develop this workstream of the FPA. And one example of this is the LTPI interface that we have recently collaborated with the OCP workgroup and is now available for the community. Right? We believe that all of these building blocks could be done the same. We just need your inputs and your help to help defining this and start working on them. Okay. Another work group that will be initialized that Tim just talked about is the SGPIO work group. If you zoom out a little bit on the host processor module FPGA that I have been focusing, you can see that the touch point for this HPM FPGA interface to the rest of the system is mostly defined by this DCSCI interface, right? So we have this serial GPIO, SOLTPI, SPI memory mapped interface that we need to find a way to define and standardize these payloads that we are defining there so we can have better interoperability between the host processor module and the DCSCM. The idea here is to develop a framework where these host processor module GPIOs are defined and described via configuration files or discovery mechanisms that needs to be defined on this workgroup, as well as the registers within the memory mapped interface. They need to be common or at least known by the BMC. So as Phillip was mentioning, you load a lot of configuration files in your BMC or the DCSCM, and without the needing to recompile the binaries, you get into an interoperability state and hopefully into a plug and play scenario, right? That's our long-term goal. So I think with that, the call to action here is to help us get into the plug and play. Tim, I'm not sure if you want to Phillip to add anything else here.
Yeah, I mean, that's the thing. We're really trying to start up these work streams within the CLA and to get to hopefully a 0.3 as quickly as possible and get a lot of ideas out there. And then, when we go to the community, see which ideas need to be pruned and which ones need to be supported and enhanced and pushed up. So that's sort of the agenda right now is getting that to the core team, getting it voted and get the work streams going. What we would like within the course of the next sort of month or two before we hit the holidays in earnest is to get that. All those work streams started up, get all sort of the administrata done, have some, as we get cycles, have some initial specs, and just get ideas down. And then once we hopefully in the starting of the first of the year, we're gonna, get all the right folks in the room and start looking at those ideas and saying, well, what makes sense and what doesn't make sense. One of the things, and this is the slide, the previous slide that you alluded to, we're going to need a lot of cross-collaboration between work streams. We know that a lot of the same cast of characters are going to be in like the SGPI work stream, the FPGA work stream, et cetera. But this, I think, is going to be, you're going to need to be more tightly coupled between work streams. You may even have, sort of collaboration days or something like that, between, folks like the FPGA work stream and the SGPIO work stream getting together and then really working through, like the SGPIO block and how that's defined within the FPGA spec. Tim, I don't know if you have any other, I'll pass it on to you.
Yeah, so we're, the very first thing is really making sure that HPM producers are unblocked and can execute as soon as humanly possible with delivering as many piece parts of their HPM that require less modifications. First and foremost, the Gerber files, ultimately the BOM, maybe, as you get through plug-in code, you're still doing, doing maybe transfer of ownership, your own signed binaries, your own, different types of provisioning, this kind of thing. So it's not necessarily what we call, plug and ship, which means you're getting an HPM off of a marketplace and directly putting it into a system factory. We understand that we're having to go through these logical steps. So we're very, we're right now pretty excited about at least having the release of the 0.5 for the type 1. I did not mention the type 2 HPM common circuit is for one SCM managing 2 nodes, and others could follow. We are also started one SCM managing more than 2 nodes, which obviously has quite a few effects because we can't just keep scaling the physical interfaces in number of times. It affects BMC silicon, it affects the SCI and the SCM size in a not good way. So, we're also working on that piece. So first and foremost is focus on the HPM programmables through the SGPI. Some of these are going to go very, very quickly once we get the work stream off. Several of the companies involved have already done this 50 times on their own, and we're now creating and doing the negotiations and basically getting it to the standards approach. So we understand what we're doing and how to get there, and now this is our vehicle in order to actually achieve what you see even out on the floor, quite a few HPMs. I can guarantee you today none of those are going to be able to be purchasable directly with any given SCM until you consume that type 1 spec, and then ultimately maybe the type 2 spec, and then immediately after. So we're trying to do these things in an order of operations that help free the HPM domains to be able to have their, everyone get the benefits of silicon diversity and whatnot. And then secondarily would be the peripherals. PCI risers, backplanes, things of that nature, which is now abstracted. We've done the things that you need to do to manage it and discover it, but today it's bring your own peripheral is the term we use, and we're really trying to get to, your PCI chem riser is not fundamentally different than mine, but we both, you make an advanced one, but at least the base one can be discovered and you can extend on top of that.
All right.
Thank you.